This is the Pearson Edexcel FP1 paper from November 2021. Let's just go straight into it. We've got a very nice question here. Just immediately get out your sheet on conics with ellipses. I've just triggered some people with my pronunciation of that word, but that's okay. So A is clearly 6, B is root 20, which is 2 root 5, I guess, which you don't really need because what we're aiming for is this, obviously the foci. So we need E, which means we need to use this formula, but of course B squared is just 20, A squared is just 36, so you don't even need to write this down really. And we have this, we solve this, we get E as 2/3, I think, when we root that and then simplify it a little bit. And then we put that value into here with A is 6 again, and we just get plus or minus 4, 0. For the directrices, we have x equals plus minus a over e, so it's just 6 over 2/3, which I believe is plus or minus 9. And we get 5 very nice free marks. Good. Use this substitution to do this. Okay, so if that is that, you always see t substitution in every single FP1 paper. It comes in 1 out of the 7 or 8 questions you'll be asked. So just make sure you remember those two results. You don't need to prove them, and it's nice to be able to do it. I might make a video on it, but it's in an exam, just remember these two results. You can get most of the others just from these, so just make sure at the very least you just memorize these 2 bits. Put those straight into there. This looks a bit like a mess for now, but 1 is the same as 1 plus t squared over 1 plus t squared, so I'll write that in twice. The reason I've done that is because now I can collect together all of this numerator under this denominator and all of the denominator under this denominator, but that means this all cancels with this, and we just end up with this. Make sure you expand the brackets here carefully, so it's 2t minus 1 plus t squared there, and likewise down the bottom. Collect all that together, divide by 2, divide by t, we get this. Now it's a little bit confusing as to how you're going to get to here, but it's always nice at this point to know what you're aiming for. So sec x is just 1 over cos, so that's going to be this over that. And then tan x is sine over cos, so it's going to be this over that, because these 2 bits cancel. That's what I mean by just memorizing these 2, and you'll be okay, I think, for the rest of it. Now, of course, how do I get from here to this plus this? Well, the denominator is wrong, right? So let's make that right by timesing this by 1 plus t over 1 plus t. That's going to give me a 1 minus t squared on the bottom, and this works out very nicely because I can just separate this bit out into a different fraction to make this, and this is just sec x plus tan x, I believe, and we'll have our answer, which is the right hand side. Excellent. Now use it to actually do an integral. So again, just put in this cos into here. We need to do something about this d theta. So dt by d theta is half sec squared, because tan differentiates sec squared. You can write sec squared as 1 plus tan squared though, which is good because tan squared is just t. So this is 1 plus t squared, which means I can divide there times by d theta, and I think we get this, timesing everything by 2 as well. And I can replace that d theta with this dt here. I also need to do something about the limits, of course. When theta is pi over 2, t is tan pi over 2, tan pi over 2 divided by 2, which is tan pi over 4, which is 1. And when theta is 0, tan of 0 is just 0. So that's fine. I'm integrating with 0 and 1. And I think I've replaced everything here in the correct way there. That I can write as 4 into 1 plus t squared all over 1 plus t squared, which will mean I can cancel that 1 plus t squared with this one. And so I can just have 4 into 1 plus t squared plus 2 into 1 minus t squared. That's cancelled with this, and then 5 times 2 is 10. And this looks doable. Just expand out the denominator. Apparently I've cancelled out these 2 first and moved the 5 outside. Okay, then do the denominator. I could have done that in one go, I guess. That looks doable. There's a formula book integral here that looks quite similar, where a is root 3, I guess, in this sense, and this will work, I think. So I think that equals that. And yeah, then we can just put in 0. Arctan of 0 is just 0, I believe. Arctan of 1 over root 3 tests your exact values there, but arctan of 1 over root 3, I believe, is pi over 6. Yeah, it is good. So we then cancel this out, and we end up with this. Arctan of 0 is just 0, so that goes away, and we have our answer there. Excellent. Question number 3. Quite a nice question, this. Using some old Tamura knowledge, for those of you who are on that journey, about how moduluses work, is, I think, the easiest way of doing this. Of course, just draw the line 2x minus 5, so you at least know what you're looking at. Here it is, 2x minus 5. I know it looks roughly like this, because when x is 2, we get minus 1. So it must be down there, and then it, of course, has gradient to y into minus 5, so it looks a bit like this. Okay, so we're clearly looking for areas where the line is higher up than the curve. So over here is good, so I just need to know that intersection, and then I can say anything over that. Between here, this intersection, and the asymptote, the line is higher than the curve. So between look for this intersection and say between that and 2, and then lastly, between here and this asymptote, the line is higher. So look for this intersection and say between -2, and that will be your last area. So I'm looking for 3 areas, this small one, and then this open-ended one over here. How do I do that? Well, using this definition in the mod here, I can just say, quite a lazy definition, but it works quite well. If x is positive, so if you're looking over this side of the graph, where x is positive, the mod function does nothing, right? When you put in +5 to the mod, you just get +5. It does nothing. So this graph here, over in this section, is just the graph x over x minus 2, nothing special. So to find these two intersections, I can just say, when does 2x minus 5 intersect x over x minus 2? Over here, that works, because the mod doesn't do anything over here. Of course, we can solve this by timesing across and expanding and collecting and so on, and we get these two answers here. I just completed the square very lazily in my head, which is why I have decimals here. I can obviously just type it into a calculator if you're doing this in real life, but I didn't have a calculator's hand at the point, so I just did it with decimals. So okay, well, clearly this intersection is going to be 2.5 plus root 1.25, which is over here. So we just want to be anything above that, because of course the line is always above the curve at that point, so we want to be anything above that. And we also want to be between 2.5 minus root 1.25, so this point here, and 2, and that will be our second point. And then over here, we can't do that, because over here, the mod function is actually doing something. We've got negative x values, so the mod function replaces x with minus x, right? If you put in -5, you times -5 by -1 to get -1 times -5 is +5, and then we have a positive mod. So this function over here is just this with a minus x there. And so, but I can do the same thing, right? I can just look for the intersection of the line, like I have done, with that new function, and I'll find this point here, hopefully. So we do that. Again, we've got exactly the same jobs to do. We find x is plus or minus root 5. Now, of course, this is going to be minus root 5, right? Where the plus root 5 would be over here, because if you did, when you do this algebra, the algebra doesn't know you're only looking over this section, right? So if you continue this graph out this way, it would intersect this line over here somewhere at positive root 5, but I don't care. This is just going to be minus root 5, and so the last boundary is between minus root 5, or the last interval I should say, between minus root 5 and minus 2, and we'll have 8 marks for doing that. So really nice. I think this is one of those questions that you want to hope to get, because as long as you know how to do this, it's a bit of work, but it's very straightforward and nice. That's good. Got some vectors here, so we've got a equation of a plane here, which I believe is the ground here. We've got a plane going in via this vector and then landing via this vector. And this is the plane that's the ground, like I said. Write down a vector that's normal to the plane, to the field or the ground. Well, that's just going to be 1 minus 225, right? Because it's written in normal form, this is that. So that's just going to be that. That's fine. Show that n, which is this, cross VA, which is that, equals this with a lambda in front. Okay, we'll do this cross this. We of course get out a matrix ijk on the top, transpose these matrices like this, and then find the determinant of this, which is going to be a vector because of the ijk's up here. So I think lots of people do this differently to how I do it, but this is just how I was taught to do it, so it's how I've always done it. So we have I times this minus this times this, which I believe is that, because the minuses make a plus there and the 2 minuses there make a plus. And then always take away this one, take away j into this times this is -1, minus this times this is -75, and then plus the k ones, this, we get this, that simplifies to that. And I believe if I factorize out 4 from that, I'll end up with this, which is perfect, so lambda equals 4, I think. When the aircraft lands, it remains in contact with the field and travels in the same sort of general direction, and travels in the direction as VI, which lives in the same plane as VA. So we've got this other plane coming out here, which these both live in. Determine a vector which has the same direction as VL. So there's a couple of ways to do this, but I think the most straightforward way is we know this n here, and I think we also know this length here, right? Or a vector for this here, because that's this, right? N cross VA. Essentially, when you cross product things, you find normal vectors to both the vectors that a normal vector to both the vectors that you've crossed. So a normal vector to both n and VA would be normal to this plane, this grey plane coming out. So that must be going off in this direction or in this direction, right? And so I think to find VL, we can just cross together. We can imagine there's a plane here that contains n and that vector we just found, and we can cross those together, right? And if we cross those together, we'll get a normal vector to this plane that I've drawn in here, which is VL. So let's cross this vector, which we don't need the lambda because that's just a constant. So let's cross this vector and this vector together, and we'll end up with, doing exactly the same kind of maths, we end up with this here, which will be a vector with the direction VL. There is another way to do it, of course, which is to say, well, okay, where am I going here? So we've got this vector here, which is going off in this direction, as I said, because it's this vector cross this vector, they both live in this plane. Crossing finds a normal vector to both, so the normal vector is off this way from the plane. If we dot that with VL, which I've called ABC, we should get 0, because that has a 90-degree perpendicular angle with VL, because VL is in that plane. But also, if we cross VL with N, we should get 0, because VL is also perpendicular to N. So you come up with these two equations here, so I'll dot it with both this and this should be 0. Now this is 2 equations, 3 unknowns, but you can just set one of them to be whatever you want, because you just can. You'll just get multiples of other things. Try not to use 0, because then you might just get 0, 0, 0, which isn't very helpful. And then of course you just solve the remaining equations that you get, and you have a vector which you can times to make a nice easier numbers, but you'll get the answer. So yeah, if you do ever forget cross products, this is quite a nice little method that will get you it. Just doing a couple of dots with the vectors that you know, and then just setting one to be whatever you want, and then you should be good to go. State limitation of the model, well, the plane might not fly in these exact straight lines there. Cool. Question number 5, so about a parabola and a hyperbola. So we're looking at these two pieces of information, so just have these to hand from this question onwards, just that you know, just in case something comes up here. So, oh look, work out the equation of the asymptotes of h. H is a hyperbola, asymptotes are here, x over a, y over b, so a is, I believe, 6, because 6 squared is 36, b is 3. So we put those into there, we get this, times everything by 6, in fact, times everything by 3, and the reason I've done that is because now this is actually the equation of a line in the way that I'm more used to seeing it, y equals mx, so the gradient is a half. That will be useful here, because line L is normal to C. So let's draw this real quick. We've got C, which is a parabola on its side, we've got H as a hyperbola like this, and we've got asymptotes to H, which are like this and this, y equals a half x, and minus a half x. So that's cool. We've got a normal to C, so there's a normal to C somewhere that's parallel to the asymptote H positive gradient. So where would the normal of C, where would a normal to C be that's parallel to this dotted line? Well, down here somewhere, right? Down here we've got a normal to C that looks like it has roughly that gradient there. So what do we do about solving this? Well, first we have to differentiate this to make 2y dy by dx equals 32. Then of course rearrange that for dy by dx. And now if I just call this point here, if the x coordinate is a, actually what I've done is I've called the x coordinate a squared, and that's mostly because when you do questions like this, that's what they do. And it's really useful because it means when you square root, you don't have to root a. Because of course if I put an a squared into here, 32a squared equals y squared, which means when I root it, I get root 32, which is just 4 root 2, and then root a is just a. Now the reason I put a minus here is of course because I'm down below the axis here, so just assuming that a is a positive number, I can put a minus into here to make it match. So this is a bit messy, but it's going to get the job done, which is fine. So what I'm going to do is I'm going to put this y coordinate into there to find the gradient of the curve at this point. Actually, no, I'm not, am I? Because I want the gradient of the normal, because I know the gradient of the normal should be a half. So what I'm going to do is I'm going to say the gradient of the normal should be minus 1 over this, which is minus y over 16. Then I'm going to put the y coordinate in, the minuses cancel, we just get this, and that must be equal to a half, because it's parallel to this line, which has gradient a half. So that must be equal to half times by 4, and so on, and cancel, we get this. And I can put that into here, right? I can say a squared must be 4 over 2, which is just 2, and minus 4 root 2, the root 2's cancel, that makes minus 8, so this makes 2 minus 8 is that coordinate. And by symmetry, I'm pretty sure this coordinate is just going to be 2, 8, wherever it is. I can't be bothered to draw it, but I think we're going to have 2 minus 8 and 2 positive 8, just by symmetry and just by not putting a minus here for the other one. Okay, good. So determine an equation for L, okay, well this is fine now because we've got y minus y1 equals mx minus x1. M is a half for this one, so y minus this equals a half x minus this. We can simplify that out. And for this one up here, the one that has negative gradient, it's going to be y minus 8 equals minus a half x minus 2. And we'll get this equation here. And those would be our two answers there. The lines L1 and L2 meet at H, so we can of course just set these equal to each other to find... sorry, they don't meet at H, they meet H. Okay, so let's look back at this. We've got the lines L1 and L2. H is the hyperbola, remember. So we're looking for when these two lines meet this hyperbola, which looks like, if you imagine, well, we can see this intersection, this one's still going to be over here as well, which is quite interesting. But I think all we have to do here is substitute this equation into the hyperbola to find when they meet, right? just like normal solving quadratic simultaneous equations. So put this into here and solve. There's a bit of, I times everything by 36 here, I think, just to get rid of this. This, of course, ends up being quite nice because this makes a minus x squared, which cancels. And we get x is 10, which means y is minus 4 from here. So that's one intersection at 10 minus 4. And the other one, we just put this into the hyperbola. And we'll get the same kind of thing. Everything works out exactly the same. We get x is 10 again, which actually just means that y is plus 4, looking at that. Good, so we have these two. Let's draw it very quickly. We have OPQ. P is this, O is the origin, obviously. P is 10 minus 4, Q is 10 plus 4. The distance there is just going to be 8. From minus 4 to plus 4 is just 8. And the distance there is obviously just 10. And so we have a half times 10 times 8, which is 40, I believe. And we'll have our answer. Excellent. Question number 6, Taylor series. Good, so we'll get out our picture for moral support. Given y equals this, show this. We just differentiate a couple of lines, right? So chain rule, dy by dx, bring the 2 down, lower this to a 1, which doesn't really matter, it's just going to be this. And then the derivative of 1 plus log x is just 1 over x, because 1 differentiates away. That differentiates to 1 over x, that's there. We can, of course, just, I think if I just immediately, okay, I thought I was going to maybe simplify that a little bit, but apparently I didn't bother. Differentiate this again with product rule. So this differentiates to 1 over x, leave this alone because it's just a 2. So that's the first bit, and then we leave this alone. The 2 is just there, we differentiate that, and that's x to the minus 1 differentiated is minus x to the minus 2. And then I think I will have simplified this a little bit, yeah. So this is x to the minus 2 with 2 of them. That's the same. We can factorize out here maybe. What have I even done here? I've expanded this out and then just noticed that these two things immediately cancel and we're left with the answer they wanted us to get. Hence finds this, so we just differentiate again. Now I wrote this, I hate quotient rule, I never use it, so I'm just going to write this as x to the minus 2 over here, and then I'm just going to use product rule again. So differentiate this one for minus 3, but that cancels, that's going to be 6 x to the minus 3 log x. Oh, sorry, use the 2, don't you? So it's 4, and then put it to a minus 3. So 4x to the minus 3 log of x, and then leave this one alone and differentiate that for 1 over x, and I believe we get this. Yeah, that looks like it makes sense to me, which we can actually then write like this, I guess, just putting the x cubed on the bottom just to make it look a little bit nicer maybe. Good, so that's going to be very useful for this. Determine the Taylor series at x equals 1. So a is 1 in this Taylor series here. So we need to work out what f of 1 is. Now f of 1 is just 1 plus log of 1, which is 0. So that's just going to be 1, squared is 1. F dashed of 1, looking over here, so f dash is dy by dx, is going to be, that's going to be 0 again, so 1 into 1 over 1 times 2 is 2. And then f dash dashed of x we're going to need, so we're going to need this evaluated at 1, which is just going to be, well, that's 0 on the top there, isn't it? Divided by 1 is just 0. And then finally this one evaluated at 1 is going to be 4 times 0 is 0 minus 2 over 1, so that's just going to be minus 2. And I think we're ready to just throw all of that information into there using, yeah, so that's 1, that's x minus 1, that's 1 as well, I think, or is that f dash? No, sorry, that's 2. And then this one here is going to be 0, right? That one's 0, so this doesn't really matter, this is a 0 there. And then this one, the next one is cubes. With a 3 factorial, that's going to be a minus 2 there. I think that just simplifies out to this. And we'll have our answer. I think this counts as simplest form. Of course, you could say this is 2 times minus 1 is minus 1, sorry, minus 2. And then have a minus 1 at the front here and then a 2x. Maybe you should write that, I don't really know. Anyway, the next bit, use the series to evaluate this. So let's replace, obviously, this bit here with this series we found. We get this. Now I've just written our extra term that we didn't use, which is just some number k, I don't know what, times x minus, that should be x minus 1, of course. I don't know why I put a 4 there. There should be a 1 there, just because it's, all I'm saying is it's the next term with some number k. I put a 4 there because I knew I needed a 4 there and just copy pasted or something like that. So that should be a 1 there where this number is. And I'm just saying that's the next term. The reason that's helpful, of course, is because some stuff here is going to cancel. So 2x minus 2x is going to cancel, and then minus 1 is minus 2, but then plus this, sorry, or minus this minus 2 is plus 2, and that all goes away as well. So all of this goes away, minus minus makes this into a plus, and then we just have all of these. Again, that should be a 1. But the reason this is good is because when you put in x equals 1, we know that this thing is going to cancel with this thing, so we just end up with a third for this first term, and everything afterwards, this should be a 1, should cancel with this to make x minus 1 to the power 1. But of course, when you put in 1, you just get 0 there. And likewise, the next one, x minus 1 to the power 5, going to cancel to make x minus 1 to the power 2, which is still 0. And so only the first term is going to matter, and it's just going to make you a third. I finally changed that to the correct 1 there. And everything else is just x minus 1 to that same sort of increasing powers, which is all just going to go away, and we just end up with the answer being a third. And I hope I've explained my reasoning clearly, if not written some bogus numbers there. Anyway, good, that was Taylor done. Question number 7. We've got the cross product form kind of way of writing a line, which is called. We don't see this very often. We don't really need it too much. It's talking about direction cosines, which again is not a question you see very often, but it's quite nice when you get it because it's not too bad. The direction cosine, the only one they've given us is this one 3/7. So the first thing we should say is, okay, well, what is OA? Well, the way that this line works here is that this is just a random point on the line, and this is the direction. So if I wrote this line in vector form, it would just be this plus t this. I would say r is equal to this plus t that. But of course that means that the coordinate for a is just this plus t that, and we can just put those together in this in one single vector. 12 plus 9t, 16 plus 6t. You can use lambdas if you prefer, but it's easier for me to type t's than it is lambdas. That's what I did. And of course that's a. Okay, so the direction cosine of OA in the x, the only one that we know anything about is the I direction, right? These are just beta gammas, they're not very helpful. We know the I direction though, so that's going to be, the direction cosine in the I direction is just cos of theta is equal to this over the size of the vector you're looking for, so this squared plus this squared plus this squared square rooted, and we know that that's equal to 3/7. Right, so because we know that the actual direction cosine is 3/7. So it's just 3/7 equal to this over the entire length of this vector, which is this, and we just solve this for t. We can notice that you can factorize out 3 from this to make 3 into 4 plus 3t, and then cancel with that 3 to make this, and that just makes everything a bit easier. We square everything. Now, squaring everything means that we've just invented a solution. You've probably seen this before. When you square stuff, you are under risk of creating solutions that don't really exist. So let's just be careful at the end of this. But for now, let's just cross multiply. You'll have to trust me that all of this simplifies down to that, which solves to this. So we have two answers, t is minus a half and t is minus 2. Which of these answers is correct? Well, let's just substitute in both into here. When you put in minus a half, you get this, and when you put in minus 2, you get this. Now, the problem with this is that we know the direction cosine is positive, so this needs to be positive, and so this can't be the correct answer. It must be this one here that's correct. So t is minus a half is the correct one to use, and we should have a is equal to that. Good, and we don't need to know anything about any of these. All you really need to know is, for that question, I think, is what the direction cosine is, which is not something you can use, not something in the book, so you just need to know these. Of course, the direction cosine for beta would be y, which is this one over the same thing. And of course, you just need to know how to dissect this into just a random point on the line and then the direction of the line. So you can then use vector form essentially like this. Good, question number 8 is, I think, the last question. It's a bit confusing when they give you this, dy by dx equals this, because you're like, well, where are the y's? How am I going to use that? This is just the general form for the iteration thing. Like if you've got x's and t's, just use dx by dt, and then put an x here, and still an h here. Right? Now h represents the kind of the span across that you're doing the iteration for. Now it's 6 hours. T represents a day, so 6 hours is a quarter of a day, I believe. So h, because there's only one iteration to get to there, is a quarter. If there were 2 iterations, then h would have to be 0.125, because you need 2 of those jumps to get to this quarter of an hour stage, but h is just 0.25 here. And we can use, we can just essentially, and actually also this isn't that useful a formula. What the textbook immediately almost says is, by the way, x0 is 3 and t0 is 0, right? Because at time 0, the pollutant, the concentration is 3. What the formula book says is that it's almost always more useful to use this. This just comes out from substituting these 2 values into here. So we get 3 plus cosh of 3. Sorry, plus cosh of 0. Cosh of 0 is 1. Makes 4 over 3 times 3 squared, which is 27. Cosh of 0 is again 1, so that's just 27. And then this tan t is 0 is 0, so this just goes away, so that's good. So that just goes away and we get 4 over 27 into there. You can type that into calculator, of course. textbook tells you that this is actually more useful than this. So just every time you're asked to do this, just use this instead. And again, you're going to have to memorize this because it's not in the formula book, I don't think. But of course, we can just evaluate this once, so we can use x zeros evaluated at 0. That should be a 0, should it not? Yeah, that should definitely be a 0. Apologies, that's the second mistake here. That should be a 0 because of course I'm just going to use this here. Going to use h as 0.25, going to use x0 as 3, and we're going to find what x1 is. So of course 1/4 times 4/27 is just 1/27, and we'll get that x1 is this. Yeah, that should be a 0. I'll fix that when I come back to it. Show the transformation this transforms into this. Now, okay, so let's just go for this then. So du by dx is 3x squared, clearly. So, okay, well, I also need to replace this dx by dt. So dx by dt, I think via chain rule needs to be du by dt times dx by du, because these du's sort of cancel. But I know du by dx, sorry, I know dx by du is just 1 over this. That's 1 over 3x squared. So therefore, dx by dt, I can just, when I come back to this, I can replace this dx by dt with just all of this. That's good. Now, what about these cosh t's and these tan t's? Well, I don't really have a way of getting from u to t very easily, so let's just leave those alone, and let's just replace this, the x's with the u's when we get to them. So let's actually just put this into the formula here. So dx by dt is equal to, have I not replaced it yet, is equal to this. All I've done here, I think, is split this fraction down the middle and say it's this over this plus this over this. The reason I've done that is because these coshes will cancel now, which is nice. I've sort of noticed that that's quite a nice thing that I can substitute in easily for. And the coshes and the tans I think I'm not that worried about because they turn up here anyway. So now I can replace dx by dt with that thing that I found earlier, which I probably should have just done here, but whatever. And now I can times everything by 3x squared, and I think I get this if you times everything by 3x squared. That looks good. Yeah, and now I can just replace x cubed with u, and I think I get this. I also moved that to the other side just to make it look exactly how they've got it. And I think that's all I needed to do. So I think it looks more complicated than it is, that question. Hence, determine the general solution of the equation from here. So this might be separable, I don't know, I haven't checked it out. I just went immediately for an integrating factor. So I just did e to the integral of this bit that's attached to the u there. Now, from the formula book, the integral of tanh is log cosh, which is really useful because then the e and the log cancel, and we just need to times this whole equation by cosh, which is useful for a couple of reasons. Firstly, because as long as I've done it right, this should integrate nicely into, this should be the opposite of a product rule differentiation. And of course, also it's nice because this over cosh goes away, which is also quite cool. But yeah, this should be the result of having done a product differentiation. Now, first thing you can do is you can write cosh tanh as sinh based on this formula here, just multiplying the cosh over. And now it's easier to see that, yeah, if you just derive u cosh t by t, product rule says do this first, you get du by dt, leave this alone, and then leave this alone and differentiate that for sinh, and you'll find good. Excellent. So then we can just integrate both sides. Cosh integrates straight to sinh, I guess, and then 3 to 3t plus a c. So that's perfect. And now we have some initial conditions, right? Or sorry, I put the x cubes back in because I have initial conditions for x and t, of course. When x is 3, we already said t was 0, so we can substitute that in. We find c is 27 because it becomes a 1, so this is 27 equals 0 plus 0, and then c is 27. Good. So we end up with this. And I think I'm kind of bleeding these questions into each other, aren't I? Because I think I've done most of this now. Find the percentage error occurred as compared to A. So A was talking about after 6 hours. So let's put t as 0.25 into here. I think I very quickly rearranged this just to find it just to have a very easy way of finding x straight away. Just divide by cosh and then cube root. And now when x is 3, t is 0, I think is the initial condition. Sorry, that's the initial condition we used earlier. When t is 0.25, let's find what x is according to the model. 0.25 because that's a quarter of a day, t is in days. So put 0.25 in, we get this, we get x as this. Now this is a decimal, I didn't bother to work out. The percentage error, this is a decimal is bigger than this, so I'm looking for a positive percentage error. So it's going to be this one minus this one over this one because we're looking compared to the value predicted in the model. So we'll call that kind of the old value. and then we'll do this, we'll times by 100, we'll go, that's a 1.05% error, and it's an overestimate, which you can very quickly verify by just typing that in and finding that it's bigger than this ever slightly, so it's an overestimate. Yeah, and I think that's the entire thing. Good.